Hello everyone, welcome back. Today we are discussing solving absolute value equations and inequalities, guys. Now, when it comes to the absolute values, okay, absolute value in and of itself, this represents the distance. The distance, let me write this down for you guys. The distance of a number from 0 on the number line. What you have to remember is that distance is always positive except for 0. So essentially, whether you're moving forwards or you're moving backwards, the distance will always be a positive value, guys. So with that said, if you were to get a problem such as this, by the way, this represents the absolute value symbols, absolute value bars. Okay, so if we're talking about the absolute value, guys, and we were to look at a concrete example, such as this next one right here, where you have the absolute value of x is equal to positive 4. Remember, the absolute value is positive. So if you take the absolute value of a positive value, the absolute value of a negative value, you will get 2 exact answers, okay? So there are 2 numbers that would satisfy this one. So essentially, this problem will have 2 solutions, x equals to 4 or x equals to negative 4. Why? Because if you take the absolute value of positive 4, you get 4. And if you take the absolute value of negative 4, you also end up with a positive 4. So essentially, there are 2 values that will produce the solutions that would make the absolute value true. So bottom line is this, guys. So if the absolute value of x is equal to c, then this means that either x will equal to c or x will equal to a negative c. So the majority of the time when you solve these absolute value problems, you will get 2 solutions. Now, there are some exceptions. Here's one exception, and one of those exceptions is this. If the absolute value of x is equal to some negative value, you cannot take the absolute value, which represents distance, and get a negative value. The distance is always positive, not negative. So a situation like this would lead to no solution, guys. So the absolute value cannot equal to a negative. If you should encounter one like that, it means no solution. Secondly, if the absolute value of x is equal to 0, then there is one solution. There will be one solution. There's only one solution that will make this problem true. So guys, there's your 2 exceptions. So if the absolute value is equal to a negative, no solution. If the absolute value is equal to 0, there will be one solution. Now, here are some steps to solving the absolute value equations, which, by the way, leads to the absolute value inequalities. So step 1, you want to isolate the absolute value, as in get the absolute value by itself on one side. Once you have it isolated, step 2, you want to create 2 equations. You could also use a compound equation. Remember that if absolute value of x is equal to c, then this means that either x will equal to c or x will equal to a negative c. Okay, guys? So this is how you would go around creating your 2 equations. Now, the next step is to go ahead and solve. If you want to add a 4th step, it doesn't hurt to add this step to check the solutions. So sometimes you will get a solution that will not make the problem true, so you cannot count it as a solution to the absolute value equation. Now, guys, here are some specific examples involving, okay, the absolute value equations. I'm going to try and do how many examples? Let's do about 3 examples and then we'll call it a day, okay? Now, number 1, the absolute value of 8 plus x is equal to 3. You notice the absolute value has already been isolated. So now you're ready to create your 2 equations. So 8 plus x, what's inside the absolute value is equal to 3. Or 8 plus x, what's inside the absolute value is equal to negative 3. Again, guys, 2 answers will produce the exact same value. There are 2 numbers that will produce the exact same values. That's why we have a positive 3, negative 3. Now you go about solving both of these. So you get x is equal to negative 8. Okay, that's this one right here. Oh, Shazam, I put negative 8. Shazam. Okay, let's fix that. Negative 5. And then you're going to come over here and solve the second one. So this cancels out, leaving you with x is equal to a negative, where's my 8? Okay, there we go. Negative 11, guys. So here, the solution set for this problem will be negative 5, comma, negative 11. And just like that, guys, we are done. Okay, here comes number 2. Now, for number 2, I've got the absolute value of 3x minus 2 plus 6 is equal to 10. Now, for this particular problem, guys, what you have to realize is that the absolute value is not isolated, so you got to isolate the absolute value first by subtracting 6 from both sides. So that leaves you the absolute value of 3x minus 2 is equal to 4. And then once you isolate it, you can break it up into 2 equations and solve both equations. So essentially, guys, when you're working with the absolute value problems, the majority of your time, they produce 2 solutions. The majority, notice I'm not saying all the time, the majority of the time they produce 2 solutions. So here's one of the solutions right there. And on this one, we're going to do the same thing, add 2 to both sides. So we get 3x is equal to negative 2. Divide both sides by 3. So the other solution would be x equals to negative 2/3. So your 2 solutions to this problem are 2, negative 2/3, and that's it. Okay, guys? 2 solutions the majority of the time. Now, let's be careful. Just because you're consistently having 2 solutions doesn't mean that it's always going to be 2 solutions. So look at number 3 right here, guys. 5 plus the absolute value of 6x plus 1 is equal to 5. If you subtract 5 from both sides to isolate the absolute value, this cancels out, leaving you with the absolute value of 6x plus 1 is equal to 0. Now, remember earlier I mentioned when the absolute value is equal to 0, that just means you're going to have 1 solution. So all you would do is take what's inside the absolute value, set it equal to 0, and solve, and this would produce your 1 solution, guys. You divide both sides by 6, so x will equal to negative 1/6. And there's your 1 solution for this one. So this one is an exception. It has 1 solution. Now, here comes number 4, and then I will discuss the absolute value inequalities. Absolute value of 5 minus 6x plus 8 is equal to 3. If I were to subtract 8 from both sides, I get the absolute value of 5 minus 6x is equal to negative 5. Now, guys, if you recall earlier, this was one of the exceptions. The absolute value cannot equal to a negative. Why? Because the absolute value is distance, and distance is always positive. Distance cannot equal to a negative. So this one will lead to no solution. But let's say you didn't know this, guys, and you attempted to solve the problem. So let's see what would happen if we were to try and solve this problem out, okay? So if we try to solve it out, what's going to happen is that we're going to end up with a number which doesn't make the original problem true. So guys, if we divide both sides by negative 6, this turns out to be x is equal to 5 over 3. Now, if we take this 5 over 3, plug it back into the original problem to check it, I want you to notice what happens. 5 minus 6 times 5 over 3, absolute value, plus 8 equals to 3. Guys, look at what happens. 3 goes into 6 2 times. 2 times 5 is 10. 5 minus 10 is a negative 5. Now, when you take the absolute value of a negative 5, what do you get? A positive 5. Is 5 plus 8 equal to 3? I don't think so. So this doesn't work. It doesn't work out, guys. Okay, so you can't count it as a solution. This is another way of verifying whether or not you have a solution. So guys, it's worth it sometimes to go ahead and check your solution. Now, here's the last part of this, guys, and that is the absolute value inequalities. I am teaching this very lightly, guys, very lightly. I'm not going to go that in depth with these type of problems, okay? There are two absolute value inequalities. First, we have the absolute value of x is greater than c. When the absolute value is greater than, this represents a union, as in we're using the word or. So if the absolute value of x is greater than c, then this means that x will be greater than c or x will be less than, notice I reversed the inequality symbol, x is less than negative c. So essentially, if you were to get this example right here, absolute value of x is greater than 4, this is asking you for what numbers have a distance of more than 4 units from 0 on the number line. Well, if you were to go to the number line, you know everything greater than 4 have a distance of more than 4 units from 0 on the number line. But guys, because when you take the absolute value of a number, it's always positive, you also have the set of values that are less than negative 4. When you take their absolute value, it will give you a positive value. So therefore, there's two intervals that will satisfy this absolute value inequality. You have an interval to the left and one to the right. So when you express this in interval notation, it will go from negative infinity to negative 4, close off the parentheses. That's the first interval. And then the second interval will be from positive 4, not included, up to positive infinity. So guys, be careful with the absolute value inequalities. If the absolute value is greater than some number, this means that you're going to end up with a union. Remember, when you're graphing the union, typically the graph is disconnected, guys. Now, I will do some additional examples in class with you, but for now, I'm just teaching you just the basics of the absolute value inequalities, all right? So here's the second type of absolute value inequality, and that is when the absolute value is less than C. This one right here reflects an intersection, and when we talk about the intersection, guys, we're looking at the word end, okay? Intersection is what two sets have in common. So if the absolute value of x is less than C, then this means that either x will be less than C, not either, it means x will be less than c and x must be greater than negative c. You have to have both of these restrictions in there in order to make sure you have solutions that make the entire inequality true. So you want values that are both going to satisfy all the numbers less than c and all the numbers greater than negative c. Now, another way to express this, guys, is as a single compound inequality, such as this one right here. Okay, this means the same thing as the previous one. So you can do it this way, or you can do it this way right here, okay? So now, what in the world does this have to do with the absolute value inequalities? So here's an example. This one right here, guys, we're gonna go to the number line. This is saying, find all the numbers that have a distance of less than 4 units from 0 on the number line. So if you go to positive 4 on the number line and you want all numbers that have a distance of less than 4 units from 0 on the number line, they would all go to the left side of the number line towards negative infinity. But the point is that, guys, the numbers do not continue indefinitely to negative infinity. At some point, when you encounter some of these numbers and you take their absolute value, it's no longer less than 4, it becomes greater than 4. So at what point do you stop? You stop at x equals to negative 4. At x equals to negative 4, it's no longer satisfying the inequality, so you want to exclude this negative 4. So you're restricting the set of elements to only include everything between negative 4 and 4. These are the numbers that will give you a distance of less than 4 units from 0 on the number line. And of course, you have to write this in interval notation, going from left to right, starting with the negative 4 and moving to the right up to positive 4. So every number from negative 4 up to positive 4, not included, guys, will satisfy this inequality. If you're not sure, what do? Test it out. If you try 0, is 0 less than 4? Yes. If we try -3, absolute value of -3 is 3. Is 3 less than 4? Yes. Okay, so test it out if you're not sure. So I am going to stop right here. We'll take some additional questions in class. So guys, we are done for today. Until next time, bye. Oh, I should have used a different color. Bye. All right, guys, and that's it. I'll see you in class.